All right, here we are with some homework help, some homework commentary. We're looking at Chapter 8, number 111. This is the structure of methyl cyanoacrylate, which I am told is one of the main ingredients in superglue. So our goal here is to complete this Lewis structure so that all of these atoms have a formal charge of 0. And there's a couple of ways to think about this. There's kind of like the longer way, which I'll do first, and then I'll show you some shortcuts because we're going to be doing a lot of this type of work in our organic chemistry unit through the rest of this semester. So where I would start for the longer way of doing this is I would start by adding up all the valence electrons in this structure, and it's probably easiest if you take the skeletal structure that you're given and like write a little chemical formula for it. So let's do that. All right, so this structure is H5C5NO2. It does not matter what order you write those in. We're just going to use it to add up valence electrons. So there's going to be 5 from the hydrogens, 4 from each carbon, 5 from the nitrogen, and then 6 from each oxygen. So that is 42 total. Okay, so there should be 42 total electrons in this structure. In this case, we have started with all the single bonds, so we can subtract those from the total. Let's see how many single bonds we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 single bonds. 2 electrons in each of those, so 42 minus 24 will give us our new total. Okay, sorry, I had to pause the video because I thought for sure that I had miscounted. So we're missing 18 electrons in this structure. All right, let's go put our 18 electrons in. We're going to start by completing the octet for things on the outside. So we're kind of like loosely following our Lewis structure steps. Now, I know in this case there's not a central atom that's clearly defined, so we're just kind of doing everything that's off of the, that's kind of like bonded to other stuff and hanging off. So, for example, this oxygen down here, we can complete its octet. So I'm going to give it 6 electrons. Okay. And then we could do the same for the nitrogen up here, another 6 electrons. All right, so now we've got 6 electrons left because I've placed 12. So I'm looking for other stuff that doesn't have a full octet. This oxygen here in the middle also doesn't have a full octet, so we'll go ahead and complete it. Give it 4. And now I have an extra pair of electrons, and again, I'm looking for something that doesn't have a full octet. And so if I come over here, these 2 carbons here are less than 8, right? They have 6 each. So I'm just going to give one of these a pair of electrons because I think we're going to end up making a double bond. No spoilers, though. All right. So that's what we've got. That's all of our electrons. And so now we're going to make sure that we move electrons around to make double bonds so that, again, we're completing the octet rule, right? So I'm going to start down here with this carbon and oxygen. We can make a double bond here to help out that carbon. Ooh, let's redo the double bond. Okay, that's a little bit better. So double bond there. We're going to take away a pair of electrons. As I mentioned over here, we're also going to do a double bond with the pair of electrons that we gave this carbon so that they get to share those. And then this carbon bonded to the nitrogen up here also needs a little bit of attention. I think we're actually going to do a triple bond there because that carbon is only bonded to one other carbon. All right, let's erase 2 pairs of electrons off of that. Okay, so now I think everything should have a full octet. Let's just go through here and just make sure. So all the hydrogens, 1 bond, that's fine. This carbon's got 4 bonds, that's good. This carbon's got 4 bonds, that's good. This carbon's got 4 bonds, that's good. This carbon, 4 bonds, that's good. This carbon, also 4 bonds, so that's good. Nitrogen, 1 pair of electrons, and then 2, 4, 6 in that bond. It's happy. This oxygen, double bond, and then 2, 4, it's happy. And then the oxygen here, two single bonds, and then a pair. So it's also happy. All right, so we placed all of our electrons, we completed the octet, and so now we can go in and we can actually look at formal charges. All the hydrogens are going to be 0. That's good. All the carbons, as long as they've got 4 bonds, are also going to be 0. So that's good. So now we have to look at our oxygens and our nitrogens. This oxygen down here has got 2 lines and then 4 dots. So that's going to be a 6 minus 6, 0 formal charge. This oxygen here in the middle, also 2 lines, right? 2 single bonds and a double bond are the same when we're thinking about formal charge, and 4 dots, so it's also going to be 0. And then this nitrogen up here, 3 lines, and then 1 pair of dots is 5, so 5 minus 5 is also 0. So sure enough, everybody is happy in that structure now. So a little bit of a longer process to get there, but I do think that as we start doing these, as you have heard me say before, I don't really like to skip any steps. We want to make sure that we're comfortable before we start taking shortcuts. So we're going to reset everything. We're going to go back to our blank structure, and I'm going to show you a little bit of a faster way, a little bit more of a shortcut to go through this one. All right, here we go, round 2. So we're back to our skeletal structure. Again, we want to get everything to a formal charge equal to 0. Formal charge actually gets a lot easier when we shift our conversation to organic molecules, because again, most of the time they want 0 formal charge on everything. And so there is a very common way that these things will bond to get 0 formal charge. So carbon's going to need 4 lines in our structure. And when I say 4 lines, that is like 4 single bonds, 2 double bonds, a double bond and 2 single bonds, a triple bond and a single bond, but there should be lines, 4 lines around each carbon. No dots though, just 4 lines. Oxygen, going to need 2 lines, either a double bond or 2 singles, and then we're going to fill in the rest with dots. So 2 lines and then 4 dots for each oxygen will give it a 0 formal charge. And then nitrogen is going to make 3 lines. So nitrogen, 3 single bonds, a double and a single, a triple bond, and then it's also going to have a pair of dots to round out its octet rule, right? So carbon, nitrogen, and oxygen are octet adhering. They will always complete an octet, and they will never go above 8. Of course, hydrogen, we know only wants the 1 single bond, so that actually makes things easy too because they're already done. We don't even have to look at the hydrogens when we go through this part. All right, so the way I'm going to work through this is I am going to do the oxygen and the nitrogen first, and then I'll figure out what to do after that. So I'm going to go to this oxygen down here. I know that this oxygen needs 2 lines around it in the structure. That means it's got to have a double bond because it's only bonded to the carbon. And then I'm going to go ahead and complete its octet, pair of electrons. All right, let's go to this oxygen here in the middle. It's already got its 2 lines. So it doesn't need to do a double bond or anything else. We're just going to go ahead and complete the octet with 2 pairs of electrons. All right, now we can pause here and we can look at the formal charge. Again, oxygen's got 6 valence electrons, so that's going to be 6 minus 1, 2, plus 4. So 6 minus 6 is 0, and then the same thing for our double bonded oxygen. 1, 2 lines, 4 dots, 6 minus 6 is 0. All right, so now we can go to the nitrogen. Again, nitrogen's going to want 3 lines. It's only bonded to the carbon, so that means that this has got to be a triple bond. And then we're going to complete nitrogen's octet with a pair of electrons, just like that. Okay, again, we can check the formal charge if we want to. Nitrogen, 1, 2, 3, 4, 5 electrons in the structure. 5 valence electrons. 5 minus 5 is 0. All right. Now, we're not done yet. We do want to make sure everybody is happy and has an octet. So we just need to make sure that all of our carbons are good now. So again, we start with the nitrogen and the oxygens first, and then we go to our carbons. Do we see any carbons anywhere that aren't happy? Oh yeah, this carbon and this carbon aren't happy, right? They only have 6 electrons around in the structure, 3 lines. So the way we're going to fix that is we're going to add a double bond between them. So let's make a double bond there. Okay, there it is. Right, so that gives each of those carbons 4 lines a full octet, and a formal charge of 0. We wouldn't double bond here because we don't want to put this carbon over 8. So this is the only arrangement where everything adheres to the octet rule and then again has a formal charge of 0. So you can do the longer way with like filling out Lewis structure and stuff. That will always work. But once you get comfortable with that, you're welcome to do the shortcut because formal charge of 0 is always going to look like this in our organic structures.